video, we're going to start solving one of the more common and more heard of questions that are asked in coding interviews, which are linked lists. And we're going to solve one aspect of linked lists that is fairly common, if you will, in in most linked list questions. So this question in particular, you understand, asks us to reverse a linked list. It asks us to reverse a linked list, right? And this is a very important thing because in most linked question, this becomes a subpart of those questions. So given the nodes of a linked list, right? Something like this. What we need to do here in particular, right? These circles are the nodes and these arrows are the connections or the links between these lists, right? So we have a list with these three nodes, and these are the red markers are the direction of those lists. Potentially, what we need to do is to cut out these connections and reverse them, right? 3 connects to 2, and 2 connects to 1 instead of 1 connecting to 2 and 2 connecting to 3, right? And at the same time, the head, which was for number 1 first, this was the head of the linked list. Let me get a color that's a little more visible. The head of this linked list needs to be reversed as well. So this was the head previously, but once we reverse the linked list, this isn't the head. This becomes the head. Right? This now becomes the head. Now, this question is relatively simple. Now, once you understand the premise of what a linked list is and what we need to do, and there are 2 ways you can potentially solve this question. There are 2 ways that we can solve this question in 2 ways. So we'll go over both of them. The first way is iteration. We move over through the linked list one by one, and the second way is to basically, recursion. So we're going to go over both of those ways. So given this linked list, as you can see on my screen right now, so what we'll do is let's stretch it out a little bit here. We'll create 2 pointers. One is the previous pointer. Again, we're going to use 2 pointers to solve this problem. If you weren't familiar with pointers, but we're going to use that, and I'm not going to go over the explanation of what pointers are, considering that that would mean that we would get into a completely different conversation than we are. This is the than we need to right now. A little finer tool here, same color. So this is the previous pointer, and this is the current pointer, right? So these are the 2 pointers we're going to be using here. So given these 2 pointers, how are we going to solve this problem, right? So let's use the red color now. Given we need to reverse the linked list here. So we're here on the current pointer here, right? So this one here is pointing to the previous pointer is pointing to the null value, considering it's not pointing to anything, right? So there's nothing we can do potentially here. So what we'll do is we'll shift the pointers. So a new pointer would come and point here, right? This is going to become the new current pointer. The C is marking that. And, and basically, we're going to make this the previous pointer. It's referred to as P. And I'm going to use the red color, I think, to showcase the previous pointers, to create a little difference here. So this previous pointer disappeared. Now that we're in this situation here, what happens is the current pointer would cut this relationship. I think one thing I missed here. Let's reverse this a little bit. Go back to the previous situation here. What would happen here is we're going to cut this relationship here and reverse it and make it point backwards, right, to the null, right? Then our current pointer would move back basically. So this current would become the new previous pointer, and we're just going to use P to refer. And similarly, we're going to use the previous color to create a new pointer here, which is going to be the new current pointer, which is now C, right? So moving back to the red color, we're going to make this pointer again change this to red to make it a little more clear, and cut this pointer here. So that's the first step that we did to reverse this linked list. Now we're here, right? The current pointer is pointing to node 2, and the previous pointer is pointing to node 1. We're going to cut this here and have 2 also point back to 1 now, right? We're reversing the linked list. So that's done. Then we cut the previous pointer here as the previous pointer moves back to this position, right? So this is the new previous pointer. So cut this up. This is the new previous pointer. And the current pointer moves to the next stage and points here, right? And this becomes the new current pointer, right? Similarly, what happens here is that it cuts its connection to the null value. 3 doesn't point to the null value anymore. It points backward to number 2, right? And that's how we conclude this. Again, previous pointer changes position. This cuts, this becomes the new previous pointer. And current pointer points to the null value here, right? Because it's not pointing to anything. Just that, presume that in this question, right? So this is the current pointer here. Again, what happens in this case again is, we end our question here, and that is how our, that's how our question is solved. So you can understand how logically this can be done, right? In the sense that potentially what we do here is our previous pointer, while pointing backwards, what it does mainly is give a direction for the current pointer to link to the previous one. So we can easily write code that links, creates links between the current pointer and the previous pointer, right? That's why we have 2 pointers pointing to each other. And dismissing the forward link, that's needed to reverse the linked list. So that's how you use iterative solution to solve this problem. Let me erase all of this here. Let's go back to a recursive solution. I'm going to use the iterative solution when I'm going to code out this problem. But it gives us, let me this stuff here, a little cumbersome. Hope that we could reverse all of this here, but I think that's the limitation of this whiteboard that we're using. So given we are starting over from the scratch, right? Given this is the linked list we have again, right? We get our value here. So given this linked list, we need to use now a recursive solution to solve this problem. And potentially in the recursive solution, our first recursive function would focus on the one that we need to reverse. That's the node 3. That's number 1, right? Because there's no connection here, we just would delete this connection here, basically to the null place, right? The pointer of 3 disappears. Then we have another recursive call, which overlaps these two. And I'm going over recursive call fairly quickly because that is not the solution I'm going to be leveraging here. Because because it's simpler if we can use the iterative solution in this case. It's a little less messy this way if you're not good at recursion. So that's in this second here, we cut this recursive call. We cut this and point number 3 there. Similarly, we do the last recursive call here, and it overarcs the entire function where it pretty much links this here, cuts this relationship, and finally points this to null, right? So that is how a recursive solution would potentially logically work for this problem. Now that we've gone over both potential solutions to this problem, let's move back and solve this problem itself. So again, we're going to use the pointers to point, use the previous and current pointers. And the current pointer would start at the head of the problem, right? So let's set this up. So you see we're pointing the current pointer to the head and the previous pointer to none. None is basically null in Python, so that's why we're using none instead of null, if you're familiar with other programming languages. So then we need to see while the current pointer has a value and while the current pointer doesn't become null, basically because as we move forward at a stage when the linked list ends, current pointer would become null, we need to do a certain set of actions. So while current factor is null, that means we can set up a while loop. So while the current pointer is not null, we need to do a series of actions every iteration of that. We need to save the next node, which is going to be next dot next. Basically, this is a Python function, the method that we're leveraging. Rather, we'll set up the nodes have been set up in this problem in such a way that we can leverage that node method here. So we're going to use next node to save the next value of the node. Next, we need to reverse the pointer. So we use the cur.next. We set the value of cur.next to previous. So we do cur.next, and which is basically, these are basically the connections. So we point that to the previous pointer, right? Next thing we need to do in this loop is to set the previous pointer to the current pointer. So we're moving up the previous pointer, current pointer value, and then we change the current pointer value to the next node after that. So once the previous pointer points at the same place as the current pointer, then we change the current pointer's value to the next node. So that is how we're going to go over the entire list step by step by step. And this is how we're reversing the linked list. Once that's done, we just return the previous value because that is the value that we need to return. So that is how we're going to show the new head of the linked list, right? So once we have the new head of the linked lists are defined in such a way that they pretty much, can build themselves. So once we have done all of that, we can run this code and we'll see that we've solved this problem. I think let me refresh this. Should console is having issues here. Code. Let's run this now. Yep, both of our cases worked properly, and with that is how you're going to solve the reverse linked list problem in Blind 75. With that, we're going to wrap this video up, and we'll see you in our next video. Thank you.